Unit 3, Lesson 8. This is the finale for linear regression. Okay, we're going to look at our Barbie bungee, back to Barbie that we started at. And it's finally time to jump. So at the end of the class period, we're going to be dropping Barbie from the height. And it's 518 centimeters in this particular one. For ours, I will give you the updated amount. But we're just going to do this for demonstration purposes. So before we drop her, we need to use everything in this chapter to calculate the appropriate length of the bungee cord. So what we did was we used the data from the very beginning. And so this is a particular group's data from the very beginning. And we need to make sure that we identify the explanatory. Explanatory, remember, is my X. And response, remember, is my Y. So remember, we're going to be doing that. So explanatory, and the way I do that is X is my X-axis. See? And so that's how I remember explanatory. And then we graph it. And remember how to graph it. If you can't remember how to graph it, let me just go ahead and write it out here for you. So, of course, the first step is to put it into a new document. And then you're going to do number 4, which is your spreadsheet. And guys, if you can't remember this, go back to the original lesson, and I go through exactly how to do it with the actual Excel. But then you're going to go ahead and label both an X and a Y column. It's X and a Y column. You can call it number of rubber bands and distance traveled. Put your data in. And then in order to graph it, you're going to do new doc. And then that's number 5, which is data statistics. And then you're going to just hover over here. And you choose the center button on your calculator and drop down menu, and it gives you, and then you choose X, and then same thing for here, Y, and then it would give you this. Also, the next thing here to be able to get your regression line, because I'll get you an actual regression line, it'll give it to you. And to do that, you're going to, from here, you're going to do menu. And you're going to go to regression. Excuse me, menu analyze, I apologize, which is analyze, which is number 4. 6 is regression. And then we're going to choose 2, which is show linear. Yes, 1 and 2 is show linear, but 2 is the way that we write the equation in statistics. So if we describe this, remember it's FUDs is that what we're going to describe, and FUDs represents form, and the form is linear or not, so that's that FUDs. U is unusual features. I don't have any unusual features. I'm looking for outliers, clusters, gaps, nothing like that. So I don't have to do the U. D is direction, and the direction is a positive direction, and S is the strength, and that's strong. The strength tells you how close the dots are on the line. It's similar to that correlation one we did when I had you guys hold up the whiteboard, and I said, okay, what's your R? Remember, R can go between -1 and +1. And remember, when it's +1, when it's equal to actually 1, it's perfect on the line. When it's -1, it's perfect on the line, but negative, and it's positive. When it's close to 0, that's when it's all scattered and like that. That would be like an R equals 0. Anyway, so estimate the correlation. You can estimate it. It's pretty close. My estimation is 0.99, but in order to actually find it, I'm going to show you how to find it, and then go back to your spreadsheet where you have your data. Make sure you're not on your data. Make sure you're on like if all your data is here, make sure your cursor is like over here or somewhere else. And you're going to do menu, and it's going to be 4A. And then the drop-down menu, you're going to have your X and your Y, and then OK. And you'll put your X in and your Y in, and then OK. Menu 4A is a linear regression test, and you can look for your R value and see what it actually is. And remember, R has no units. So you are just going to just say that the correlation represents how close it is to the line. And remember, if we changed my X and Y, so if this was rubber bands and this was distance, and R is equal to 0.99, and I changed it to rubber bands here and distance to here, you can try to go ahead and change it on your calculator, and you can do menu 4A again, and you'll see that R does not change. The equation, which you should have gotten from either the line that I just told you or menu 4A, notice that's my Y, and that's my X. And notice though how I'm writing it out. I'm making sure I'm writing it out in distance and then rubber bands. Okay, the slope of my line Now, remember, this is written on the cabinet up in my room, but remember here, for each rubber band added, and that's my X. And then this is a really important word because the line that we're doing is just a predicted line. So you got to make sure you have that, otherwise you don't get your full points. The predicted distance traveled, that's my Y. And it increases by, and then this is my slope. Now, one thing I do want to point out to you, I know in Algebra 1, your slope was like 2/3 or -8/4 or whatever. In stats, we always use just a decimal, and it's always per one rubber band. That's per one increase of X. Okay. The y-intercept, so you saw, sorry, I should have also, you notice the slope is right next to here, next to the rubber bands. The y-intercept is 25.33, and that's this number here. And that just means I have 0x. And my x is rubber bands, so that means 0 rubber bands. Really, if you think about it, that's just how tall Barbie is. Remember, we had her stretched out with her arms up or hair down or whatever, or extended, but that's basically Barbie's height. So you can tell me kind of what it means. So when there's no rubber bands, we predict. Remember, the word predict's really important because the line is just a prediction line. The distance traveled to be 25.33, because this here, guys, this is the prediction line. And so if I put 3 into that, it's going to give me here. And this here is just a prediction. So the prediction with rubber bands is that Barbie would go about 42 centimeters. That's just my prediction. That's not what I actually go necessarily, but it's my prediction. Obviously, if it's right on the line, very close to like this one, then the prediction and the actual is going to be exactly the same. But the line is just a prediction based on my data. All right. Number 10, calculate interpret the residual. So remember, I'm going to wrap. You don't want Miss Brown to wrap, but that's okay. I'll wrap. Residual equals actual minus predicted. All right, there's wrap. So the first is the actual. It says for 4 rubber bands. So let's go up and look at 4. For 4 rubber bands, I have here is 55. And so that's my actual. So 55 minus my predicted. To do my predicted, I have to use my regression line. So notice I'm using this line that I already have, and I'm just going to put 4 in for my X. So that's just the line that I already came up with, and I'm going to put that in my calculator and get 55.37. So then I'm going to, as it shows, 55 is my actual minus 55.37, and that's going to get me negative 0.37. And so what that means, let's go up to our line and look what that means. So that means my actual is 55, and my predicted's 55.37. So for 4 rubber bands. So for 4 rubber bands, this is my line. And then for 4 rubber bands, I'm here. Oops, hold on. Sorry, I'm going to get it straight. There we go. So I'm going to say this is my actual. Oh, it keeps going off. I'm sorry. All right, that's my predicted here. And my actual's right here, which is right below it. So my actual's here, and my predicted's a little bit higher than it. Let's just kind of zoom in, and you can see this is my actual minus my predicted, and this is my residual. And so you see the actual is just a little less than the predicted. It's pretty good as the prediction, but my prediction's a little bit too high because it's above the actual. So that's why the answer is here, that the actual distance is a little less than the predicted, so the predicted is too high. The actual is less than the predicted's higher than the actual. Sketch the residual plot. To do the residual plot, you can, on your calculator, go Menu, Analyze, Residual, which this is 4, 7, and then 2 is Show Plot. I believe so. But it's definitely Menu, Analyze, Residual, Show Plot. Remember, these here are just, you can see this here is just the difference of the line. And if you go back up to the line itself, you can see that it's going to be the same thing. That if I can get a good line, there we go. You can see that these here are just the same distances that my residuals are. It's just basically magnified. My residuals are all my leftovers. And this here is the prediction line right here. So these here, the prediction is too low. And these here, the prediction is too high. And we're looking for a random scatter. We're looking for acne, and it looks pretty good. It looks like acne. It's random scatter. I don't have any particular pattern. It's just kind of spread all the way, all over it. For R squared, you also are going to look for R squared. You're going to look at your spreadsheet because that's that menu 44A that you will see. R squared is just literally you take R, and R was 0.99, and you square it. And what this is 98% of the variability. The variability is just all of the Y, all the Y that we missed by, is accounted for by my line. So it's saying, hey, I just have 98% that's accounted for, and this is the left that's left. So I have a lot that's accounted for, 99.8%. So only 0.2% is not accounted for. That means it's really accurate, and that's why when you actually look at the line, almost every dot is really, really close to the line. Find the standard deviation of residuals. What a standard deviation of residuals is, you know the definition of standard deviation is average distance from the line. Standard deviation of residuals is average distance that the residuals are from the line. And that is also on menu 44A, and you'll see that value, and then this is how you interpret it. Is this linear appropriate? And yes, this is the things you want to see. You want to see the residual plot has no pattern, so we're like, good, we're just random scatter. One thing that's also not on here that's really important is that your original line is pretty straight. You look at it and you go, well, that's straight enough. There's no big curve in it. But if the residual plot has a random scatter, the original line is going to be straight. But that's what we usually start with, is we're like, okay, that's pretty straight. Let's look at the residual plot and make sure it's okay. R squared is very close to 1. And S is pretty low because S, remember, is my average distance that these guys are from the line. So clearly, I don't want these to be that far away from the prediction line. I want these all to be pretty close. So those are kind of the things to look out for. You're going to use your model to predict the number of rubber bands that you need to have the most exciting bungee jump at 518 centimeters. Remember, ours is a little bit different, which I will give it to you, and then you get to go out and you get to try it. So then you'll just go out to the hallway, and you'll go ahead and try it, and make sure you do it exactly how you did it when you did the original experiment, so that you can get similar results. And you can check. And so for this particular one, it was 65 rubber bands. And so you would use 65 rubber bands, and you'd put Barbie on the side, and you'd try it, and you'd see if she's going to be safe, and hopefully she'll just land right before, and there she goes. Hopefully she'll land right before here, and she'll say, yay, this was fun, and she won't have a massive headache. So that's the goal. So you'll have some people actually go down to the floor to see if she is hit, because even if her hair brushes, because we are predicting with the hair. So if her hair brushes, then that's a fail. So let's see how good your predictions are. All right, I hope you enjoyed this lesson, and if you have any other questions, please let me know.